In section 6.8, we're going to be looking at some more applications that involve percents, and in this section, we're going to look at personal finance. We're going to be looking at simple interest, compound interest, also mortgages, and also certificate of deposits and other things that deal with personal finance. We'll start off with the simple interest formula, and the simple interest formula is always going to be the formula I is equal to P times R times T. I is going to be the interest that is earned. The P is the principal or the original amount of the loan. The R is the annual interest rate, which is always in the form of a percent. And the time is always going to be in years. And it's very important that we have the time of a particular investment or loan be in years. Because if it's in months or in days, then we must convert that into years. And to convert the number of days or months into years, we will use these formulas. T is going to be the number of months divided by 12, if it's in months. Or if it's in days, then we'll take the number of days and divide that by 360. Okay, so that's very important. And we'll look at some examples that deal with simple interest. Like in this particular problem, Mr. Simpson took a $3,500 loan at 14% simple interest for 3 years. And we want to find the interest to be paid at the end of the term. So here we use the formula I is equal to P times R times T. So that means that the interest is going to be $3,500 multiplied by 14%. Keep in mind to change 14% to a decimal, we drop the percent sign, move the decimal point 2 places to the left, so it'll be 0.14 times 3 years. So if we multiply that out, you'll get $1,470. So the interest that will be paid at the end of 3 years on a $3,500 loan at 14% simple interest will be $1,470. All right, here's another example. Here the Wilson family took a loan of $30,000 at 23% simple interest for 24 months. And here we want to find the balance to be paid at the end of the term. Now here the time is given in months. We still use the simple interest formula I is equal to P times R times T. Now here the principal is $30,000 that would be multiplied by 23% or 0.23. Now since we're given months, we're going to have to take the number of months and divide that by 12. So it'll be 24 over 12, or 24 divided by 12, which will be 2. So now you have 2 times 0.23 times 30,000, and you'll end up with $13,800. So that's the amount of the interest that will have to be paid over the 24-month term. Let's say that Ms. Thompson, in this case, borrowed $300 at 10.9% simple interest for 45 days. And we want to find the balance to be paid at the end of the term. In this case here, we're given 45 days as the time, so we'll have to take the 45 days and divide that by 360. We'll still use the simple interest formula of I is equal to P times R times T. So that's 300 times 10.9% as a decimal is now 0.109, multiplied by this time 45 over 360. Now 45 over 360 will be 0.125. Then that will be multiplied by 0.109 times 300. And your interest to 2 decimal places, since we're dealing with dollars and cents, will be 4.09 or $4.09, which will be the amount of interest that Mrs. Thompson will have to pay at the end of 45 days. Now, some people opt to pay their loans early as a means of reducing the amount of interest that they will have to owe at the end of that particular term. So here borrowers can make a payment before the maturity date to reduce the amount of interest owed. So here, we're going to have to compute the problem in two parts. Before the partial payment, we have to find out what the interest is before the partial payment, and also find out what the interest is after the partial payment has been made. Now, here's an example of this particular situation. Let's say that John took a $25,000 loan at 7.5% simple interest for 18 months. After 10 months, he paid back $5,000. Find the amount of money he saved by making a partial payment. Okay, so here we're going to have to do this in two parts. Let's find out what the interest is before the partial payment. So here we're going to find out the interest was for after the first 10 months. That's why I have I sub 10. That represents the interest after 10 months. That's going to be $25,000. That's going to be multiplied by 7.5%, which is 0.075, multiplied by 10 over 12, because it's given in months, so we have to convert that to a fractional part of a year by dividing by 12. So when we multiply that, you'll get $1,562.50. That's the interest after the first 10 months. So here, when we adjust the principal, we have $25,000. We're going to add that to the $1,562.50, but we're going to subtract from it the $5,000 payment that John has made. So now that adjusted principal becomes $21,562.50. Okay, so now we need to find out what the interest is after the partial payment was made. So let's find out what the interest is after 8 months, or for the remaining 8 months. So his adjusted principal is $21,562.50. We'll take that, multiply that by 0.075, and that's going to be multiplied by 8 out of 12 months. That's the remaining 8 months of the 18-month term for that loan. So when we multiply that out, you'll get $1,078.13. So here, to find out what the balance is, we have that $25,000 plus that $1,562.50 minus the $5,000 that he paid early, plus the $1,078.13, and you'll end up with a final balance of $22,640.13. Now the question asks is find out the amount of money that he saved by making a partial payment. Let's look at how much interest he would pay at the end of 18 months. And that's this formula, I is equal to P times R times T. That's the $25,000 times 0.075 times 18 over 12. So after 18 months, his interest will be $2,812.50. Okay, now, what I have here is the sum of the interest that he paid for the first 10 months, and then the interest that he will have to pay for the remaining 8 months. We found that out to be $1,562.50 for the first 10 months. And then we'll add that to the $1,078.13 that we found out earlier for the remaining 8 months. Add those two together, you'll get $2,640.63. Now, if we were to subtract that $2,812.50, which is the interest after 18 months, minus those partial interest of $2,640.63, he would have saved $171.87. So by paying back that $5,000, he has saved $171.87. Okay, here's another application of percents. or personal finance, and that's mortgages. Most families will take out a loan that's called a mortgage to buy a house. Now, most mortgages will last either for 15 or 30 years, and people need to determine the two features. What will the monthly payment be, and what is the total amount? An amortization table is used to help calculate a monthly payment. Now, in your textbook, you do have an amortization table for a 15 and for a 30-year mortgage at various interest rates. Okay, so here you'll use that to help you calculate the monthly payment. So the table shows the effective rate factor for a 15 and 30-year mortgage on a $1,000 house using different possible interest rates. And here's an example of that amortization table. As you can see, that's the amortization table for a mortgage, principal, and interest for every $1,000. Okay, so in this case here, if you have a 15-year mortgage at 4.00%, the effective rate factor in this case will be 7.39688. Okay, so that's the number that you'll use to multiply by the amount per $1,000. And let's look at some examples of mortgages. Like Mary's going to buy a $120,000 house and wants to make a 25% down payment. Find the amount of mortgage she needs to take. So here the down payment is going to be a 25% down payment. So 25% as a decimal would be 0.25 times $120,000. That would give her a down payment of $30,000. So the amount of the mortgage in this case will be subtracting the $30,000 from the $120,000, which will be $90,000. So the amount of the mortgage is $90,000. Okay, here's another example. Now this is where we use the effective rate factor, or that table 1 in your textbook, which is the amortization table. Stephen is going to take a $350,000 mortgage for 30 years at a rate of 5.15%. Find his monthly payment. Okay, so here, since our table gives us a mortgage principal and interest per $1,000, we have to take that $350,000 and divide that by $1,000. Then it's going to be multiplied by the effective rate factor, which is where our amortization table comes in. And here it is. So here we're looking at a 30-year mortgage, which is this column right here, at 5.15%. So if we read across, and in this column for 30 years, that effective rate factor is 5.46026. Okay, that's the number that we're going to be using. So you have 350,000 divided by 1,000, which is actually 350. Then take the 350 and multiply that by 5.46026, and you'll get $1,191.09, which is going to represent the monthly payment that Stephen will have to make on a $350,000 mortgage for 30 years at 5.15%. Okay. Now let's say we want to find the monthly payment. Here the Johnson family is going to buy a house at $590,000. They plan to make a 20% down payment and then take out a mortgage for 30 years at a rate of 4.65%. Find out what their monthly payment is going to be. Okay, here's how we will solve this particular problem. Here the down payment is 0.20 times $590,000. Okay, 20% as a decimal is 0.20. Multiply that by $590,000, you get a down payment of $118,000. Then we're going to subtract that $118,000 from the $590,000 to get the mortgage amount, which is $472,000. And with that $472,000, that's where we'll calculate the monthly payment, which is going to be that $472,000 divided by $1,000, which is, of course, 472. Then you go to your amortization table and find 30 years for 4.65%, which will be 5.15637. Okay, so you use that amortization table, look under 4.65% as your interest, and then look under the column for 30 years, you'll see 5.15637. You'll multiply that by the 472 to get $2,433.81. That's the monthly payment that the Johnson family will have to make on a $590,000 house if they take a 30-year mortgage at 4.65%. Okay, now here we're going to compare two different mortgages or terms. If the mortgage amount is $400,000, what terms will provide a smaller monthly payment? A 15-year mortgage at 4.30% or a 30-year mortgage at 5.80%. Okay, let's look at part A and find out what that monthly payment is. Now, the effective rate factor for a 15-year mortgage at 4.30% is 7.54811. So we'll have $400,000 divided by 1,000, which will end up being 400. Then multiply that by 7.54811. You'll get $3,019.24. That will represent the monthly payment for a $400,000 mortgage at 15 years at 4.30%. But what about a 30-year mortgage at 5.80%? Well, here, this time the effective rate factor for a 30-year mortgage at 5.80% would be 5.86753. So now you have $400,000 divided by 1,000, which is, of course, will be 400 times 5.86753, and you'll get $2,347.01. So if you were looking for a smaller monthly payment, then a 30-year mortgage at 5.80% will give you that smaller monthly payment. Now we're going to look at the same terms and the same amount of mortgage, but this time we want to find out which one will provide a smaller total amount of money to be spent in order to pay off that mortgage. Okay, so a 15-year mortgage at 4.30%. We found out that the monthly payment was $3,019.24. 15 years at 12 months. We have to convert years to months because we're looking at monthly payments here. 15 years at 12 months will be 180 months. So take your $3,019.24, divide and multiply that by 180 months, and you'll get $543,463.20. That's going to represent the total cost of paying off a $400,000 house or a $400,000 mortgage. Now, for a 30-year mortgage at 5.80%, you can see it's a higher amount. The monthly payment there was $2,347.01. Now, 30 years at 12 months is 360 months. Multiply that by the $2,347.01, you'll get $844,923.60. So in this case here, a 15-year mortgage at 4.30% will provide a smaller amount of money that you'll have to pay, a total amount of money that you will pay on that mortgage. Okay, so if you get more years on it, then obviously it's going to cost you more money. Fewer years, the monthly payment may be more, but in the long run, you won't have to pay it'll cost you less in the end. All right, invest in CDs. Here's one of the most popular and safe investments that most people use, and it's called a certificate of deposit, or CD. What it does, it guarantees a fixed simple interest rate. The interest is usually paid in full at the end of the term. So in this case here, as an example, let's say that Robert bought a $25,000 5-year certificate of deposit, which pays a simple annual interest of 2.95%. Find the amount of money he will receive in the end of the 5-year term. In this case here, we use the simple interest formula I is equal to P times R times T. The principal is $25,000. The rate is 2.95%. As a decimal, it will be 0.0295 multiplied by 5, and that will give you the interest of $3,687.50. So the amount of money he will receive at the end of the 5-year term, if you add that to the $25,000, that grand total will be $28,687.50. That's how much that Robert will receive at the end of the 5-year term. Let's look at compound interest. Here, interest is calculated several different times over the length of the investment, and we call that compound interest. One common type is called annual compound interest, which means that each consecutive year's interest is calculated on the balance at the end of the previous year. So here we'll be working these type of problems in several different parts, one step each per year. So let's look at this example here. Now I'll walk through this step by step. Let's say that Paul bought a $25,000 2-year CD which pays 4.02% interest compounded annually. And we want to find the balance earned by the end of the 2-year term. Okay, so let's look at the interest after the first year. That's going to be $25,000 multiplied by 0.0402 when you convert 4.02% as a decimal times 1 year. We're using a simple interest formula. I is equal to P times R times T. Now when we multiply those numbers together, you'll get $1,005. That's at the end of the first year. Now the balance at the end of the first year will be the $25,000 will add that interest of $1,005 to it to get $26,005. Okay, so now that's going to represent the new principal. So now we want to find out what the interest is at the end of the second year. So now we use the $26,005, which is the principal at the end of the first year, multiply that by 0.0402 times 1, and you'll get $1,045.40. Now, the balance at the end of the second year is this. You add that $1,045.40 to the $26,005, and you'll get a final amount of $27,050.40. So the balance, or the amount at the end of the 2-year term on that $25,000 CD, compounded annually at 4.02%, will be $27,050.40. All right, next is shares of stock. Shareholders receive their profit by buying stocks for a low price and then selling them at a higher price. The buyer or the seller must pay a brokerage fee, and that's the amount of money paid to the bank that actually negotiates the stock trade. And an example of this, well, here's how we solve shares of stock problems, and it involves 4 steps. 1, you calculate the cost of buying the stock, and that includes the brokerage fees. And number 2, calculate the revenue for selling the stock, and that also includes the brokerage fee as well. Then you're going to calculate your net profit. and then you're going to subtract the initial cost. All right, let's look at an example of just that. Here, Marina bought 20 shares of Dollar Incorporated at $12.38 per share and sold them at $18.02 per share. 2.25% brokerage fee should be paid on buying or selling the stocks. And here we want to find the total brokerage fee. And also we're going to find the total profit. Here's how this works. We first calculate the buying price. Here Marina bought 20 shares of stock of Dollar Incorporated stock at $12.38 per share. So if you multiply the 20 shares at $12.38, you'll get $247.60. That's the buying price. She's also going to have to pay a 2.25% brokerage fee. So 2.25% as a decimal will be 0.0225. Multiply that by the $247.60. So here she paid a brokerage fee of $5.57. And then the total cost, you'll just add the brokerage fee to the buying price. So $247.60 plus the $5.57 will give you $253.17. So that's the total cost, or the buying cost, for those 20 shares. All right, next she sold those stocks at $18.02 per share. So here, $18.02, we're going to multiply that by the 20 shares that she sold them. So she sold them at a total of $360.40. But there's also a brokerage fee too for selling those stocks. So we multiply 0.0225 by the $360.40 to get $8.11. That's the brokerage fee for selling those stocks. And the total revenue, we'll have to subtract $8.11 from the $360.40, and she'll end up with a revenue of $352.29. Now, to answer that question there, the total brokerage fee, we add the brokerage fee that she paid when she bought the stocks and the brokerage fee that she paid when she sold them. That's the $5.57 and the $8.11. We add those two together, you'll get that $13.68. That's the total brokerage fee that was paid on buying and selling the stocks. Now, let's say we want to find out what the total profit is. Here's what we do. We take the total revenue, which is $352.29. We subtract from it the total buying cost of $253.17, and that profit will be $99.12. So Marina made a profit of $99.12. Okay, so that will conclude everything in section 6.8.